Alright, so what I'm going to do is this is part 2 of prepping you for the exam. Whenever it says neutralize, that means we're going to do number of H pluses because they love this in the multiple choice. Molarity of the acid, volume of the acid is equal to the molarity of the base, the volume of the base, and then the number of OHs. So that's the equation we're going to use. Now, think about this. I'm going to pop in. I have to pay attention to the number of H's and the number of OHs. So there's going to be 1 there, and there's going to be 2 there. And then basically I'm going to pop in the values. They give me 0.05 molar HCl. They want to know volume, so that's going to be my X equals. And then in this case, I have 0.1 molar NaMgOH, and then 50 is my volume there. So the first thing I'm going to do is get X by itself because it makes it easier to see kind of what's going on. So I get a 1 and a 0.5 when I move those all around, little algebra. Bust out a little cross multiplication, so I end up with that. So the 1 can go there. And then basically I am going to end up doing, what am I going to get here? I'm going to get, at this point I'm going to get 100 up here. So I get 150 times that. A tenth of anything, you just move the decimal over. So I'm basically going to end up with 10 over 0.5. Which ultimately, when I go to do the calculation, is going to give me 0.5 is going to go into 1 20 times, and then because basically it's going to go into 1 20 times in 10, or you could put in scientific notation. You could go 1.0 times 10 to the first if you're a little rusty with your math. 5.0 times 10 to the negative second. 1 divided by 5 is going to be 0.2. And then I'm going to get, when I go to add this, I'm going to 1 plus a negative minus a negative 2 is going to give me to the negative, is going to give me to the 10 to the third. So that's going to basically mean I'm going to go 1, 2, 3, and that means it's going to be 200. So you can set it up that way, put in scientific notation, or just do the math. Either way you want to simplify it. But when it says neutralization, you want to make sure you use that equation. Next one. What is the Ka of the acid? X squared. Kind of feel like I did this one in the other video. Molarity Ka, a little redundant, but it's the same idea. 1 molar solution, I'm going to go 1.0 times 10 to the 0, just because scientific notation is the way to go. X squared, who doesn't love it? pH of 5 automatically means 1.0 times 10 to the negative fifth. So then I got to square that. So I'm going to come down here. And I'm going to do 1.0 times 10 to the negative fifth. When I square a number in scientific notation, that's going to give me 1 to the 10 to the negative 10th. And that's basically being divided by 1. So my Ka is going to be 1 times 10 to the negative 10th. Just make sure you put everything in scientific notation. Makes your life easier. Remember, Ka times Kb equals Kw, right? So think about this. Like if they ask you to compare which one's stronger, like as this goes up, think about this. Like here, I have my value for Ka is 1 times 10 to the negative second here. This is my Kw is 1.0 times 10 to the negative 14th. Think about this. The larger this number is means the smaller mathematically that number is. Because sometimes they'll ask you on the exam, they'll say, hey, well, which one, which one's stronger, which one's larger. The larger the Ka value, see how this has a 1 times 10 to the negative second. When I go to calculate this value, watch what I get. I get 1.0 times 10 to the negative 14th. I'm going to divide this by 1 times 10 to the negative second. 1 divided by 1, 1. 14 minus a minus 2 is going to give me 1.0 times 10 to the negative 12th is going to be your answer for 37, right? So that's going to be your answer. But what does that basically mean? It basically means that this is a stronger, the Ka for this, the acidic value of this is, as this gets as a stronger acid, that means the conjugate base gets weaker. Right, that's basically, so think about a strong acid. A strong acid has a valid mass of Ka, which means its conjugate base is basically has a value of 0. That's why they're heartbreakers. So the weaker the acid, the stronger the conjugate base. So vice versa. That's one thing you can think about mathematically when you're comparing acids and conjugates. All right, this one, same thing as before. We go number of H's, molarity of the acid times the volume of the acid is going to be equal to the molarity of the base times the volume of the base and the number of OHs. Okay, so if we look right there, then what I'm going to do is I'm going to pop in the values they give me. I got to pay attention to the H's, so there's 2 H's in that right there. I see the 2 H's. The molarity of, it's 0.2, just 0.2 molar. Put that in there. The volume is 100, goes right there. How much? 0.1. Let's see here. How much of volume, and then this is going to be 1 right there. So then when I basically go and set it up, what I want to do is I slide everything over. So I'm going to get 0.1 over here, move that over there, and then 1's going to go over there, and then it's going to be equal to x, the volume I'm trying to solve for. Well, the first thing I see is 0.2 divided by 0.1 is going to be 2. So I'm basically going to give me 2 times 100, which means my value is going to be D. Set up and solve. If you need to put in scientific notation, I would put in scientific notation if it makes it easier for you to process it. Next one, 39. It says after the put a required amount of 0.01 NaOH into 0.02 H2SO3, what would the pH of the resulting solution be? Well, if you notice, remember we talked about moles, right? It says talking about to neutralize, what would the pH of the solution be once it's neutralized? So when you talk about neutralizing, what does that mean when it's neutralizing? It means that you basically add equivalence is basically what it means. So when you add equivalence, think about it like this. I have H2SO3 plus OH, Na, well, we'll do this. We'll do it like this. We'll go plus NaOH. First thing we want to do is cancel the heartbreakers. So what's going to happen is it's going to automatically take an H, it's going to make water, and we're going to have plus HSO4 minus. Now, this side's always going to be 0 at neutralization. So the pH at equivalence, because it's talking about neutralizing, which is the same thing as equivalence, is going to be dictated by what's on the right-hand side. In this case, I have a negative ion. That is going to react. The negative ion, HSO3 minus, is going to react with water because negative ions take H's. Shoplifts, ends up making OH minus and H2SO3. That means this is going to make the solution basic. That's why whenever you have a titration that goes to a weak acid titration, at the end, you produce a conjugate base is left over. Because the only thing you have left is a conjugate base, it'll be basic. So that means my D is the correct answer. It's going to be between 8 and 10. It's going to be a slight base. It's not going to be really basic. It's not going to be 7. The only way something would be 7, think about it like this. If I have HCl plus NaOH, and I react those, cross out the heartbreakers. Well, I have H plus and OH minus. The only thing left on this side is water. Since that's the only thing left, that's why it's a pH of 7. If you think about a weak base titration, so we think about NH3 plus HCl. Cancel the heartbreakers, gone. We just have H plus. We're only going to get NH4 plus over here on because the H always gets tacked on. On this side, I have a positive ion. Positive ion, what does it do? It's going to react with water. Positive ions give H's, or Bronsted-Lowry acid gives an H, makes H3O plus and NH3. So at equivalence, the pH is going to be less than 7 because you're creating a conjugate acid. So think about that because they ask that in different forms on the test. 40. Which of the following species will be increased when HCl is, so net ionic reactions, they love to ask these. All you do is cancel your heartbreakers. HCl, HC2, H3, O2. Heartbreaker gone. So what am I going to be left with? So if I, it's solution of HCO3 and water. I got to read that. So what that means, this is going to break up into HC2, H3, O2 minus. Actually, let's start that one again. I didn't read the question completely. It's saying you have HC2, H3, O2, and you're going to react with water. It's talking about what happens in water. Well, when you put an acid in water, it's going to transfer an H, and you're going to get H3O plus. That's why it's an acid a little bit, and C2, H3, O2 minus. When you dump HCl in solution, you're really just dumping H plus. think about this, because you're making like a mini buffer solution, but not really, but kind of. This isn't the greatest problem in the world. But I have an acid and I have a conjugate base. The acid always cancels out bases. The bases always cancel out acids. So when I add H plus to the solution, C2H3O2 is what's going to react with it, ultimately producing C2H3O2, or from a Le Chat point of view, if you add this in there, it's going to shove it back this way, and it's going to say which of the following will be increased. So what's going to be increased is actually Roman numeral 3, HC2H3O2. But think about that when we add stuff in solution as well. If I took a buffer solution, because this is a good point to make, because they like to ask this, if I create a buffer solution like here, right? Buffer has to resist changes in pH up and down. This is my acid, this is my conjugate base. So if I add a base to it, a base always gets canceled, so the acid drops in at that point, takes care of business. What it does is it transfers an H, makes a little agua fresca, and C2H3O2 minus. Bam, neutralized. Okay? Or the other option is, what if you take that same solution, because I'm going to ask you net ionic tomorrow, so just cancel the heartbreakers. What if instead I added HCl? Well, really, I'm adding H plus. Who takes care of an acid? Conjugate base leaps in there, and we go C2H3O2 minus, and ultimately what we're going to put together is HC2H3O2. Not directly connected to this problem, but I know I'm going to ask you that, so I figured I'd bring it up. Get over it. Next one. Next question. They love to ask these on the exam. So what kind of solution is it? So watch. First thing I do, I'm hunting the heartbreakers. You have to know your heartbreakers for the exam. You need to know them for tomorrow. So watch. I'm going to cancel K. So that's going to give me this. An acid, and a negative ion, conjugate base, thank you. Cancel heartbreaker, cancel heartbreaker, cancel heartbreaker. The only thing I have is H plus. That's basically just going to be an acid. NH3, heartbreaker. Okay, I have a weak base, and I have a conjugate acid, a positive ion. If we look here, I have a weak base, because the NH group at the end, and I have OH. So this is going to be a really basic solution. And then I have H plus, OH minus. That's going to give me, when I basically neutralize it, because it says equal amounts of each. So they ask you, who's the most acidic? Well, B is going to be the most acidic because all it has is H plus in there. Solution with the closest pH to 7, that's going to be E, because I have a strong acid and a strong base. Buffer with a pH of 7, or greater than 7 actually. So that means it's going to be a buffer solution that's basic. That's going to be D, because I have to have a weak base, NH3, and a conjugate acid, NH4 plus. But the base is what's going to make it basic. A buffer with a pH of, did I just flip that around? pH that's going to be less than 7. That's going to be A, is going to be your answer for that one. And you should be good to go with that. Now, next thing it asks, Ka of hypochlorous acid is this. Calculate the pH. So it's asking the pH. So it's basically x squared over molarity is equal to Ka. Same thing, we've kind of done a few of these. My Ka is 3.0 times 10 to the negative 8 equals x squared over 3.0 times 10 to the negative 2nd. So watch, I'm going to multiply these numbers. I'm going to get 9, and then negative 2 plus a negative 8 is going to be ultimately 10 to the negative 10th. So when I take the square root of it, I'm going to square root it. I'm going to get 3 times 10 to the negative 5th. Now normally we would just look at this and be, okay, boom. That's going to be our pH, we'll take the negative log of it. But that's usually when this is 1.0. What I'll tell you is as this number goes up, this number will decrease. So since this isn't 1.0 times 10 to the negative 5th, it's 3.0. It means that, and they rarely do this on the exam. Whoever wrote this doesn't understand the exam questions that well. But that's why C isn't the correct answer. It's actually going to be D, because the front of the scientific notation number is 3.0, and this is to the negative 5th. That means the pH has to be below 5, and that's the one that's going to be closest. That's going to be below 5. They don't typically give you numbers that don't match that well, but it's still good practice. Just use the math trick. 66, they ask you about preparing a buffer. Desired pH is there. You don't have a calculator, but the first thing you're going to do is get pKa, because we picked the pKa, the closest pKa to the pH is what we want. So what I'm going to do right here is I'm going to just do this. Now this is 7.2, so this is going to be a little bit below 3. This is 6.3. That's going to be a little bit below 8, and that's going to be a little bit below 13. Well, a little bit below 8, that would be the acid we would use. So we go H2PO4 minus, and we would pair that with this conjugate. That's our acid. Conjugate base means taking H off, so HPO4 2 minus would be our conjugate base right there. So that would be the values, and that's going to be, where do I see that? Oh, this is kind of weird looking. Where is it here? Be H2PO4. Kind of weird looking. Oh, it'll be here. Be this. Be A. Next one, 74. Which of the procedures would produce a buffered solution? So if we look, cancel my heartbreakers, gone, gone. Cancel my heartbreakers, cancel my heartbreakers. The first thing you notice is I just have OH minus and H plus. I know Roman numeral 1 is not going to be possible. When I look at number 3, I know I have a conjugate base because I got C2H3O2 minus and the weak acid, so I know number 3 for sure. This one comes up a lot on the exam. It's kind of tricky because it says equal volumes, but notice the molarity is half the molarity of the acid. So what does that mean? Well, think about it in a titration. If I go HC2H3O2 and I'm titrating with OH minus, right? What am I going to get on the other side? Water, and I'm going to get C2H3O2 minus. If this was 1, and this is in a Backum table, and this I'm adding 0.5. I'm going to go minus 0.5, minus 0.5, plus 0.5 on the other side. When I'm done at the end of it, I'm going to actually end up with 0.5 on this side and 0.5 on this side. So by titrating it halfway, you actually create a perfect buffer solution because I have the exact same amount of HC2H3O2 as C2H3O2 minus. So it's a perfect buffer solution, and they love to use this on the exam, and I may even include it tomorrow. You want to look at that. So then basically D is my correct answer. They're both buffer solutions. This one, the key giveaway is, look, half the molarity of the strong versus the weak means you're going to be halfway to equivalence, means you get a perfect buffer halfway to equivalence. And I believe that's the end of it. I'm trying to think if there's anything else I need to, let me just check real quick if there's anything else I need to go over. Let's see. Okay, pH stronger. I think I covered everything. We are good. We're all set. So make sure you study, review everything. You should be good to go. If you paid attention to everything that was in this video, you should be able to rock that test. Have a good day.